In electronics and telecommunications, modulation is the process of varying one or more properties of a periodic waveform, called the carrier signal, with a modulating signal that typically contains information to be transmitted. The first form of radio frequency modulation was wireless telegraphy, called continuous wave modulation, which remains the most basic form. In telecommunications, modulation is the process of conveying a message signal, for example a digital bit stream or an analog audio signal, inside another signal that can be physically transmitted. Modulation of a sine waveform transforms a baseband message signal into a passband signal. A modulator is a device that performs modulation. A demodulator is a device that performs demodulation, the inverse of modulation. A modem can perform both operations. The aim of analog modulation is to transfer an analog baseband signal, for example an audio signal or TV signal, over an analog band pass channel at a different frequency, for example over a limited radio frequency band or a cable TV network channel. The aim of digital modulation is to transfer a digital bit stream over an analog band pass channel, for example over the public switch telephone network or over a limited radio frequency band. Analog and digital modulation facilitate frequency division multiplexing, where several low-pass information signals are transferred simultaneously over the same shared physical medium, using separate passband channels. The aim of digital baseband modulation methods, also known as line coding, is to transfer a digital bit stream over a baseband channel, typically a non-filtered copper wire such as a serial bus or a wired local area network. The aim of pulse modulation methods is to transfer a narrowband analog signal, for example a phone call over a wideband baseband channel or, in some of the schemes, as a bit stream over another digital transmission system. In music synthesizers, modulation may be used to synthesize waveforms with an extensive overtone spectrum using a small number of oscillators. In this case the carrier frequency is typically in the same order or much lower than the modulating waveform. Analog modulation methods. In analog modulation, the modulation is applied continuously in response to the analog information signal. List of common analog modulation techniques. Common analog modulation techniques are amplitude modulation, double sideband modulation with carrier, double sideband suppressed carrier transmission, double sideband reduced carrier transmission, single sideband modulation with carrier, single sideband modulation, suppressed carrier modulation, vestigial sideband modulation, quadrature amplitude modulation, angle modulation, which is approximately constant envelope frequency modulation, phase modulation. Digital modulation methods. In digital modulation, an analog carrier signal is modulated by a discrete signal. Digital modulation methods can be considered as digital to analog conversion, and the corresponding demodulation or detection as analog to digital conversion. The changes in the carrier signal are chosen from a finite number of alternative symbols. A simple example: a telephone line is designed for transferring audible sounds, for example tones, and not digital bits. Computers may however communicate over a telephone line by means of modems, which are representing the digital bits by tones, called symbols. If there are 4 alternative symbols, the first symbol may represent the bit sequence 00, the second 01, the third 10 and the fourth 11. If the modem plays a melody consisting of 1000 tones per second, the symbol rate is 1000 symbols second, or baud. Since each tone represents a message consisting of 2 digital bits in this example, the bit rate is twice the symbol rate, i.e., 2000 bits per second. This is similar to the technique used by dial-up modems as opposed to DSL modems. According to one definition of digital signal, the modulated signal is a digital signal. According to another definition, the modulation is a form of digital to analog conversion. Most textbooks would consider digital modulation schemes as a form of digital transmission, synonymous to data transmission. Very few would consider it as analog transmission. Fundamental digital modulation methods. The most fundamental digital modulation techniques are based on keying. PSK. A finite number of phases are used. FSK. A finite number of frequencies are used. ASK. A finite number of amplitudes are used. QAM. A finite number of at least 2 phases and at least 2 amplitudes are used. In QAM, an M-phase signal and a quadrature phase signal are amplitude modulated with a finite number of amplitudes, and then summed. It can be seen as a 2-channel system, each channel using ASK. The resulting signal is equivalent to a combination of PSK and ASK. In all of the above methods, each of these phases, frequencies or amplitudes are assigned a unique pattern of binary bits. Usually, each phase, frequency or amplitude encodes an equal number of bits. This number of bits comprises the symbol that is represented by the particular phase, frequency or amplitude. If the alphabet consists of alternative symbols, each symbol represents a message consisting of n bits. If the symbol rate is symbols second, the data rate is bit second. For example, with an alphabet consisting of 16 alternative symbols, each symbol represents 4 bits. Thus, the data rate is 4 times the baud rate. In the case of PSK, ASK or QAM, where the carrier frequency of the modulated signal is constant, the modulation alphabet is often conveniently represented on a constellation diagram, showing the amplitude of the I signal at the x-axis, and the amplitude of the Q signal at the y-axis, for each symbol. Modulator and detector, principles of operation PSK and ASK, and sometimes also FSK, are often generated and detected using the principle of QAM. The I and Q signals can be combined into a complex-valued signal I plus JQ. The resulting so-called equivalent low-pass signal or equivalent baseband signal is a complex-valued representation of the real-valued modulated physical signal. These are the general steps used by the modulator to transmit data. Group the incoming data bits into code words, one for each symbol that will be transmitted. Map the code words to attributes, for example amplitudes of the I and Q signals, or frequency or phase values. Adapt pulse shaping or some other filtering to limit the bandwidth and form the spectrum of the equivalent low-pass signal, typically using digital signal processing. Perform digital to analog conversion of the I and Q signals. Generate a high-frequency sine carrier waveform, and perhaps also a cosine quadrature component. Carry out the modulation, for example by multiplying the sine and cosine waveform with the I and Q signals, resulting in the equivalent low-pass signal being frequency shifted to the modulated passband signal or RF signal. Sometimes this is achieved using DSP technology, for example direct digital synthesis using a waveform table, instead of analog signal processing. In that case the above DAC step should be done after this step. Amplification and analog band pass filtering to avoid harmonic distortion and periodic spectrum. At the receiver side, the demodulator typically performs band pass filtering, automatic gain control (AGC), frequency shifting of the RF signal to the equivalent baseband I and Q signals, or to an intermediate frequency signal, by multiplying the RF signal with a local oscillator sine wave and cosine wave frequency. Sampling and analog to digital conversion. Equalization filtering, for example a matched filter, compensation for multipath propagation, time spreading. phase distortion and frequency selective fading, to avoid intersymbol interference and symbol distortion, detection of the amplitudes of the I and Q signals, or the frequency or phase of the F signal, quantization of the amplitudes, frequencies or phases to the nearest allowed symbol values, mapping of the quantized amplitudes, frequencies or phases to code words, parallel to serial conversion of the code words into a bit stream. Pass the resultant bit stream on for further processing, such as removal of any error-correcting codes. As is common to all digital communication systems, the design of both the modulator and demodulator must be done simultaneously. Digital modulation schemes are possible because the transmitter-receiver pair have prior knowledge of how data is encoded and represented in the communications system. In all digital communication systems, both the modulator at the transmitter and the demodulator at the receiver are structured so that they perform inverse operations. Non-coherent modulation methods do not require a receiver reference clock signal that is phase synchronized with the sender-carrier signal. In this case, modulation symbols are asynchronously transferred. The opposite is coherent modulation. List of common digital modulation techniques. The most common digital modulation techniques are phase shift keying, binary PSK using M equals 2 symbols, quadrature PSK using M equals 4 symbols, 8 PSK using M equals 8 symbols, 1/6 PSK using M equals 16 symbols, differential PSK, differential Q PSK, offset Q PSK, pi 4 Q PSK. Frequency shift keying, audio frequency shift keying, multi-frequency shift keying, dual tone multi-frequency, amplitude shift keying, on-off keying. The most common ASC form MARY vestigial sideband modulation, for example 8 VSB. Quadrature amplitude modulation, a combination of PSK and ASC. Polar modulation like QAM, a combination of PSK and ASC. Continuous phase modulation methods, minimum shift keying, Gaussian minimum shift keying, continuous phase frequency shift keying, orthogonal frequency division multiplexing modulation, discrete multitone, including adaptive modulation and bit loading, wavelet modulation, trellis-coded modulation, also known as trellis modulation, spread spectrum techniques, direct sequence spread spectrum, chirp spread spectrum according to IEEE 802.15 for ACSS uses pseudo-stochastic coding. Frequency hopping spread spectrum applies a special scheme for channel release. SIM31 New Digital Mod, SIM31, SIM63 TKSSWL Tunisian, MSK and GMSK are particular cases of continuous phase modulation. Indeed, MSK is a particular case of the subfamily of CPM known as continuous phase frequency shift keying, which is defined by a rectangular frequency pulse of one symbol time duration. OFDM is based on the idea of frequency division multiplexing, but the multiplex streams are all parts of a single original stream. The bit stream is split into several parallel data streams, each transferred over its own subcarrier using some conventional digital modulation scheme. The modulated subcarriers are summed to form an OFDM signal. This dividing and recombining helps with handling channel impairments. OFDM is considered as a modulation technique rather than a multiplex technique, since it transfers one bit stream over one communication channel using one sequence of so-called OFDM symbols. OFDM can be extended to multi-user channel access method in the orthogonal frequency division, multiple access and multi-carrier code division. Multiple access schemes, allowing several users to share the same physical medium by giving different subcarriers or spreading codes to different users. Of the two kinds of RF power amplifier, switching amplifiers cost less and use less battery power than linear amplifiers of the same output power. However, they only work with relatively constant amplitude modulation signals such as angle modulation and CDMA, but not with QAM and OFDM. Nevertheless, even though switching amplifiers are completely unsuitable for normal QAM constellations, often the QAM modulation principle are used to drive switching amplifiers with these FM and other waveforms. And sometimes QAM demodulators are used to receive the signals put out by these switching amplifiers. Automatic digital modulation recognition. Automatic digital modulation recognition in intelligent communication systems is one of the most important issues in software-defined radio and cognitive radio. According to incremental expansive intelligent receivers, automatic modulation recognition becomes a challenging topic in telecommunication systems and computer engineering. Such systems have many civil and military applications. Moreover, blind recognition of modulation type is an important problem in commercial systems, especially in software-defined radio. Usually in such systems, there are some extra information for system configuration, but considering blind approaches in intelligent receivers, we can reduce information overload and increase transmission performance. Obviously, with no knowledge of the transmitted data and many unknown parameters at the receiver, such as the signal power, carrier frequency and phase offsets, timing information, etc., blind identification of the modulation is a difficult task. This becomes even more challenging in real-world scenarios with multipath fading, frequency selective and time-varying channels. There are two main approaches to automatic modulation recognition. The first approach uses likelihood-based methods to assign an input signal to a proper class. Another recent approach is based on feature extraction. Digital baseband modulation, or line coding. The term digital baseband modulation is synonymous to line codes. These are methods to transfer a digital bit stream over an analog baseband channel using a pulse train, i.e., a discrete number of signal levels, by directly modulating the voltage or current on a cable. Common examples are unipolar, non-return to zero, Manchester and alternate Mark inversion codings. Pulse modulation methods. Pulse modulation schemes aim at transferring a narrowband analog signal over an analog baseband channel as a two-level signal by modulating a pulse wave. Some pulse modulation schemes also allow the narrowband analog signal to be transferred as a digital signal with a fixed bit rate, which can be transferred over an underlying digital transmission system, for example, some line code. These are not modulation schemes in the conventional sense since they are not channel coding schemes, but should be considered as source coding schemes, and in some cases analog to digital conversion techniques. Analog over analog methods. Pulse amplitude modulation, pulse width modulation and pulse depth modulation. Pulse position modulation. Analog over digital methods. Pulse code modulation, differential PCM, adaptive DPCM. Delta modulation. Delta sigma modulation. Continuously variable slope delta modulation, also called adaptive delta modulation. Pulse density modulation. Miscellaneous modulation techniques. The use of on-off keying to transmit Morse code at radio frequencies is known as continuous wave operation. Adaptive modulation. Space modulation is a method whereby signals are modulated within airspace such as that used in instrument landing systems.